Hello students, welcome back. Previously we went through the general form of a quadratic function. Now our focus is the next form, which we call the vertex form. In general, the general form ax squared plus bx plus c can be transformed into the second expression here, which we call the vertex form. Y equals to a times x minus h complete square plus k. And how do we find h and k? It turns out, from the general form, we can calculate h and k through these formulae. H is negative b over 2a, and k is negative of b squared minus 4ac over 4a. If we have time, we'll come back and discuss why that is the case, and that's 2.3. But if we don't have time, then we'll just move on because that's rather tedious. But everybody should remember the formulae. Now when a is greater than 0, as we discussed, we have to have concave up. We have this kind of graph, and minimum k, this k value, that's assigned at x equals to h. This one right here, if I plug in h, then h minus h is 0. So this entire thing drops out, and we have this minimum k. And range is k to infinity, and as you can see, symmetric with respect to the vertical line, x equals to h. Is everything clear to you? On the other hand, when a is negative, we have this kind of graph. Concave down, we have maximum instead, y equals to k, this k value, at x equals to h, right here, h comma k, the vertex. And the range is negative infinity to k, and symmetric about the vertical line, x equals to h. Because this h and k determine the vertex right here, or there, this expression here, the second expression, is called the vertex form of a quadratic function. Now let's work about some application of vertex equations in example 2.4, and then examples 2.5 and 2.6 will talk about how to convert the general to vertex, but let's do it one step at a time. Easier problems first. Okay, part A. Find the vertex equation of the quadratic function that is symmetric to the vertical line, x equal to negative 2. That has a maximum 3 and a y-intercept, negative 1. Alright, it says vertex equation, so this is what you have to do. So let's look for f of x equals 8 times x minus h squared plus k. And then the problem said x equals to negative 2, that's a line of symmetry, so that must go through the vertex, so h is negative 2. Maximum is k, so k is 3. So here, basically, right there, we're doing this. hk is negative 2, comma 3. So x is negative 2, vertical line, so that's h. And maximum k, that's 3. So plug in negative 2 right here, and 3 right there. Make sense? So okay, let's go ahead and do that. Negative 2, and then that's 3. And, oh, nobody writes like this. X minus of negative 2 squared. Too complicated. Yeah, that's why you write. Okay, we use x equals to negative 2 and the maximum 3. We have yet to use this. Y-intercept is negative 1. So let's go ahead and do that. Y-intercept, how do you find our y-intercept? We have to plug in x equals to 0, right? 8 times 0 plus 2 squared plus 3, and that has to be negative 1. And from here we can find a value. Make sense? 2 squared is 4, so 4a plus 3 equals -1. That's not too bad. 4a equals to -4, right? You're getting a equals to -1. And then a is negative, so we have to have maximum. Yeah, it makes sense. And so on and so forth. So right here, a value is -1. So there you go. That completes the problem. As a matter of fact, I skipped a lot of explanations in between. I just gave you the skeleton, just formulations only. But if you look up this answer key, then you have everything. First, you begin with the vertex equation, and then, vertex equation, x -2, y equals to 3, those are there, and then plug in the y-intercept condition. So plug in x equal to 0, and we have this relation from here. So for a, we did it, and then got a value, put it back in, and we get the desired equation. By the way, here's a graph. Same graph, y-intercept -1, and then vertex -2, 3. Yes, everything makes sense. Oops, wrong key. Here's a full solution. So vertex equation, and apply the y-intercept. So for a, and that'll give you the desired answer. One more time. Basically, the same problem again. Vertex equation for x equal to -1/2. Okay, that's a line of symmetry, and minimum -2. So this time we have to have something concave up, and y-intercept -1/2. Good luck. Did you try? Stop the playback and try. Let's check. See if you got the right thing. So here's a vertex equation. I already used up f, so let's use g. A times, which we don't know yet, x plus 1/2 squared. Yeah, -1/2. And then minimum -2. Good. H, k values. And then intercept is -1/2, so plug in x equal to 0. Then I get intercept -1/2. From here, I can find out the a value. So 1/2 squared is 1/4. 1/4 a minus 2 equals -1/2. We get this equation, and let's solve for a. Step 1 is denominator, multiply by 4, so we have just a. 2 times 4 is -8, and -1/2 times 4 is -2. Okay, alright, flip this -8, and we get a equal to 6. So that's the conclusion, a equal to 6. Yeah, plug in 6. 6, x plus 1/2, complete square, minus 2. And if you plot that, then you get, well, pretty much what's expected as a matter of fact. And -1/2, comma -2 right here, vertex. And then the y-intercept is right here, -1/2. All right. We just went through a couple of example problems associated to the vertex equation. And vertex -2, 3 explicitly there, and then we have additional condition. From there we can find that a value. Similar problem there. In any case, everything revolves around this vertex equation. We're going to come back and discuss a bit more about these kind of problems in the separate videos. Maybe 2 more videos, because we have 2 more example problems here,